So now we are going to see about one image classification use cases for CNN architecture. Here we are using CIFAR-10 dataset. CIFAR-10 means Canadian Institute for Advanced Research. We call it as CIFAR. So it has only 10 classes images. So it means what's the image now? Frog, truck, and deer and car and bird and horse and sheep and cat, like only trained. It is also pre-trained model, so it has only 10 classes. So it has only 10 classes. Okay, I'll tell you one by one. So first you have to understood this importing, why we are importing. So guys, why we are importing warnings? Now tell me, why we are filtering warnings?
To ignore any warning,
Ignore the warning
not to
signs.
get rid of.
Why we are importing numpy? For mathematical
Or mathematical operation.
yes,
Yeah.
mathematical operations or mathematical computations also. And why we are importing pandas here?
To
Data,
read files.
data manipulations and analysis. And why we are using
Yeah.
matplotlib for data visualizations. So
For data
uh,
visualization.
we have data set in Keras, so we can easily import as a CIFAR-10. And come to model. So what are the things we needed to build the model? Sequential, load model, convolutional 2D, max pooling 2D, and flatten and dense. Here the new members will be there: dropout layer and batch normalization. I tell you, so what is dropout layer, what is batch normalization. So and here I'm importing the Adam optimizer. Okay, and the next one is evolution metrics. Here I'm using the classifications reports, right? I tell you one by one. So just here I am loaded the CIFAR-10 data set. So it automatically separate the train X, train Y, test X, test Y. Okay. Now see the shape here. Now tell me, what is the training data shape? So you guys, you people assume that. So I already draw one data set, right? I already draw one data set in CNN concept, right? For in X column all images will be there, in Y column all the labels will be there. So now tell me, so what is the size of X shape? What is the size of X shape? What you people are understand while seeing the
32 by 32, 3 is an RGB color image.
super, and 50,000 means
The quantity of
no, so it has 50,000 samples.
1000.
Yes, and now tell me, so what is the Y? So here we have 50,000. I already told, right? Before comma we call it as rows. After comma we call it as column. So it has 50,000 rows and one column. Have you got my point? Guys, this is the X. This is the
Okay.
X column. This is the Y column. Have you got my point? I already draw. Just now you people are taking the
Yeah,
step, right? So and the next one is how many will be testing?
10,000,
So total how many samples we have?
60,000.
So 83,
60,000.
83% is going for training and remaining 16% will be going for testing. I'll show you. Just guys, if you given train X shape, it automatically finds the train X shape. If you are given train Y shape, it automatically deducts the train Y shape. And the next one is round of percentage. Guys, if you want to find the percentage, what you people are done, so you have to divide it by 50,000 divided by 50,000 divided by 60,000, right? Yes or no? Is Gautam?
Yeah.
Can you
So
please repeat the point?
if you want to find the percentage of training data, you should
Hmm.
divide it by 50,000 divided by 60,000, right? So we have
Yeah,
60,000.
number of values by total number of
So
values, correct.
you can add. So train X shape 0, train test X shape 0. So if you're adding train X shape 0, train Y train X test X is 0. So what is the, if you're adding both, what's the number?
60,
60,000, right?
60,000.
Divided by 60,000. So here train X shape 0 means shape 0.
50,000.
uh, so 50,000 divided by 60,000 means it find one value and we have to multiply by 100. We have to multiply by 100. Okay, and so this is the round function. This is the round function. If you are giving comma 2, it only returns the 2-digit points. After decimal, it only returns the 2-digit points. Have you got my point?
Yes.
Guys, slash n means if you are using the slash n inside the codes, it automatically returns as the next line.
New
So
line.
new line. Have you got my point? So if I am using slash n here moving on next line. So here I am moving on new line. So here moving on new line. Same. Have you got my point? So kindly do the code, guys. Don't waste your time. So have you understood this? Say yes or no.
I understand. If you are not giving slash n, the testing
There is
data
no
will
new
come
line.
close to training data.
There is no
There won't be
spaces
a
will be there.
space extra space line.
Yes, not in new line. Okay, and we will just checking how many unique data will be there using numpy function. So it finds from train y, and you can find the len value. So now see what are the labels will be there. 0 to 9, I already told, right? Only 10 data will be there, and the total number is 10. So now count the number. How many numbers will be there? 10 numbers will be there. Have you got my point? Yes.
Yes.
Okay, so this is the visualization. We already seen while I'm taken matplotlib. I already shown this subplot image, right? So subplot means, so I'll tell you. So what's the number? I need 10 image. I need 10 image. What's the figure size? So each image has a 15 height and width, right? 15 height and width. So for loop, so range 10 means what are the number will be print? 0 to 9. If range 10 means what are the number will be present? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We will not take 10. Have you got my point?
Yes.
So if n is 10, so how many columns will be there? So this is a subplot. One row, first row, how many columns will be there? 10
And
columns. So this is the position. I already told, right? So this is the position. So what's the position now? If the I is 0, if the I is 0, 0 plus 1 means what?
one.
1. What's the first position here? Frog. First position, second position, like that, 10 positions right there till 9. 9 plus
So
1 means 10. So it automatically returns x train 0, y train 0 means it returns the image and return the label as a top. So because I am giving in the title, right? So here printing here. Do you have any doubts, guys? Do you have any doubts here?
no.
You can give 20 also. Your wish. Have you got it? So here the truck will be there, bird will be there, and frog and cat. So many images will be there. You can give your wish, guys. You can give us a 4 subplot. You can give us a 3 subplots. It automatically shows the image. So it automatically trained as a pre-trained data sets. Have you got my point? It's easy. Okay.
But
And the next one is you can again, you people are converting as a divided by 255. You people are divided by 255. You can give us a -1. You can give us a -1, or else you can give us a train X shape. So how many data will be there in train X shape? We have how many? We have train X. We have 50,000. And how many we have? Testing for
in my
10,000
time
points.
column.
Is have you got it? Is so this is the shape here. So this is the shape of train X, train Y. So we just convert as a float. So we already know. So 50,000 for training, 10,000 for testing. Have you understood? Is
Yes.
so guys, this is very important. This is like our tiger image. This is like our tiger image. So first one is the input size, right? 3232 height and width, and the channel is what? 3. So why I am using batch normalization means while training the data should be in stable. Okay, it will not remove any. I already yesterday told, right? So if you are sharing any photos from iPhone to normal phone, the quality will be different, right? So your image quality, yes or no?
Yes.
But if you are using batch normalization, it sends the same quality. if the iPhone has same the image as a sorry, like 1 MB, and the same thing another mobile also will be sent as a same 1 MB image. Have you got it? Like stable learning. Have you got my point? While training the data should be in stable. Okay, then only I'm using the batch normalization. You already know convolution layer, so it has a 32 filters and the kernel size is a 3 cross 3 matrix. And here I'm using the activation rule. I just given the input shape. I just given the input shape 32 32, like 3 is the channel and max pooling is the size, right? So what is the shape of here? 2 cross 2 matrix, right? Yes or no?
Yes.
So and another one is I'm using the 64 filters. Guys, this is the rule like that. We will give like that. So you can give as a 2, 4, 8, 16, 32, and 64. And what about the 64? 64, 128, right? You can give like that filters. Okay. So the size is 3, and this, if I'm using padding, same means what it happens if taking the image including padding, right? So activation.
Yes.
So you people are already know Platinum layer will convert as a 2D to 1D. Yes. So here I'm using the units as a 64. So what is our output? So this is the CIFAR-10. So we have 10 classes only. So here I'm using the softmax, right? Yes or no?
Yes.
Okay, guys, don't worry. Just a minute. I'm just compiling the data using Adam, and here I'm using sparse categorical cross entropy. I already told right yesterday. You just see the data set, last functions, and given the metrics, accuracy, and summary. Okay, you people just understand. If I'm using none, none means in pandas we already use. None means it shows the all columns, right? It means all samples. Have you got my point?
Yes.
So all samples should have what? Imagine this is the tiger image. Imagine. So what is the height and width? 32 32. What is the channel?
RGB.
Yeah. So,
Okay. Come to next convolutional layer. So what is the height and width?
30 by 30.
How many
three,
filters we have?
32.
32 filters.
32.
So what it happens? Convolutional while I'm using pooling layer, what it happens? It reduces the size, right?
Size of the image.
So guys, don't assume this is the half of the size. So it will be using the formula. So here I'm given the formula. Okay, so don't compare like that. So the 15 image, 15 height and width should be in. Here I'm using convolutional layer. What it happen? It extract the features, right? So here the 32 filters will be there. Here what it happen? 64 filters will be there. Now here the max pooling, what it happens, it reduces the size. It reduces the size of 64 filters, right? Yes or no?
Yes.
Hmm. And what about the next one? The flatten layer. So you can multiply all the number. You can get the flatten layer. If you people multiply these three numbers, you will be get the number of 3136 flatten layer. So all the layers will be connected as a 64 dense vector, and 64 dense vector also connected as a 10. So this is the trainable parameters. This is the trainable parameters. Okay. Do you have any doubts here, guys? Do you have any doubts in this table? So if you are giving the summary function, it automatically summarize the what are the things will be happen inside the model building. Have you understood? So these are the trainable parameters, these are the non-trainable parameters. So it's in kb and b. So b means byte, kb means kilobyte. Have you got my point? Alkan Gautam?
Yes.
Okay. And just I'm fitting. So just listen. Here I'm using 15 epochs and validation testing and given. So it automatically takes us from text y. Here I am initializing epochs is what? 0. Okay. Just to see what is the accuracy now? 54. What is the validation accuracy? 64. Now see at the end. So what is the accuracy now? 93.
93.
So what is the validation accuracy? 70.
70.
If you are using multiple epochs, so it may be in more. Okay. So just to see, guys, see. So here I'm using 15 epochs. So what is the range here? 1 to 16, right? 1 comma 16, right? Yes or no?
Yes, before the epochs have been 15. Now we are adding 1 to the
Yes,
previous
yes, yes,
epoch.
yes, yes. We just give model 1. So what is the name of the variable? Model 1. Model 1. So dot history means if you are using accuracy, you can use directly use this object. You can use accuracy, loss, how whatever it presents like that, you can type like that. Validation accuracy, validation loss. So it will be shows the history. It will be shows the history. I'll show you. It will be shows the history like this. Okay, okay, and the next one you just run it, and the next one, guys, the next one you just give the epochs and loss train and loss validation. This is our loss of training loss, validation loss. Okay, so what it happen, loss will be increased, right? Loss will be increases, right? What you people are
Yes.
observing, what you people are observe the images, training.
Yes, it's
So all are
increasing.
increases, but loss should be in decreases, right? Loss should be in decreases, right?
Mm.
Hmm. Then another one. So accuracy. Here I am using accuracy and epoch. So now see the accuracy, validation accuracy and training accuracy.
Yeah, trading accuracy is
Accuracy will
increasing.
be decreases, right? But accuracy should be in increases. Yes or no? Okay.
Yes.
Yeah, yes.
And we will give another. So then only what we people are observe, model one is performing very good in training and with accuracy is 90 percentage, but what it happened, not performing good with validation data will be what, overfitting, right? Yes or no? Our validation data will be overfitting, right? Yes. So then only we are moving another model. You can change the model. You can update another convolutional max pooling. You can update another dense layer. So it do you have any doubts in this cell, guys? So whatever I thought in previous cell, that much of data one bit will be, codings will be there. Do you have any doubts here? Batch normalization, convolutional pooling, and flatten, do you have any doubt? So we can extra additionally we can add the layers. Do you have any doubts here? Say yes or no, Gautam?
No.
Alka?
Mm.
Here the same I'm using the optimizer and same concept, guys. 30 to 32 height and width. The channel is 3 and the convolutional layer is 30-30. And the filter is what? 64 filters. So max pooling means it reduces the sizes, right? Same concept. Have you got my point? So if you're multiplying these three things, then only you will get a flattened layer. Have you got my point? Say yes or no?
Yes.
Okay. Okay, guys, the training epochs will be takes too much of time. See, this will takes 10 milliseconds. Okay, if you are using 5 epochs, it may have 1 minute. Okay, it takes too much of time. Okay, so here I am using the accuracy will be 80 and the validation accuracy will be 71. The same thing I will see in the history, accuracy loss plot, loss and epoch. See what it happens, loss will be decreases, right? Loss will be decreases. Now accuracy will be increases, right? So in previous graph and here also there are many differences, right? Yes or no?
Yes, the training accuracy and the validation accuracy has increased.
Mm. So what it happen means reduced trainable parameters. The trainable parameter will be reduced. Now see the first one. Now see the first one. So what's the trainable parameter now? 220. Just imagine 220. Okay. Now see the trainable parameter here. So what is the trainable parameter here?
28.
Yes. So here's the less KB, right? So here's the less KB trainable parameter. So then only we will reduce the overfitting, right? Yes. Okay, so here adding few more layers with the batch normalization and dropout. So we will reduce the overfitting. I tell you, you people know batch normalization. So batch normalization means while training the data, so it automatically train the data as in stable model. Okay, so I tell you. So in the dropout layer function, so we will give what's the percentage now. 30 percentage. Okay, so while training the model, it automatically remove the 30 percentage of data to reduce the overfitting. Have you got my point, guys? Have you understood what is dropout layer? Have you understood? Is Alkan Gautam, and here I am removing dropout. While training the data, it removes the 50 percentage. It means the many images has noises, right? Yes or no? So in CIFAR-10, I have more than images, like 60,000 or 70,000. I think 60,000, right, Gautam?
Yes.
So 60,000 images have some images have more noises, right? So while training the data, so it automatically drop 50 percentage of images. Okay, have you understood?
Okay.
Hmm.
Okay.
So now see the you people are easily understand this summary. I know. And so guys, these will be take 60 seconds. So one epochs will be takes 1 minute. One epochs will be take 1 minute. Okay, so definitely it will takes half an hour or 1 day. So kindly do the coding. Okay, so see now the validation loss is super. It lost perfect, and the accuracy will be increases perfect, right? So with the addition of dropout, as overfitting will be reduced, but a model is oscillate. Trying to settle will be late. The learning rate will be late, right? So, guys, just assume the model will be trained as a half an hour. The model will be trained as a half an hour. But before I'm using model 2 and 1, it takes us a few minutes. Have you seen the difference? Yes or no?
Yes. Yes.
Hmm. Then kindly do the code, guys. This is very important. If you train the model, you can save as the CNN.Keras. Okay, no need to train several times. If you trained once, you can store as the Keras file. You can store. So model 3 is best for us, right? So then only I am saving the model 3. Have you got my point? If your model 2 is best, 1 is best, you can train the model and store save as the model. Have you got my point? Yes.
Yes. Yes.
Mm. So another one is I also save the weights. I also save the weights. So you can save like that. You can give any name. I just given the CNN. You can give any name, but the remaining thing you should be there. So dot keras and dot weights and height h5 it automatically stores. Okay. So and CIFAR-10 also one of the trained data set. Okay, like keras store. If you want to use in your project, you can just load it. You can just load the model and load the weight. So see what are the 10 classes will be there. 0 represents aeroplane, and 1 represents automobile, bird, cat, deer, dog, frog, house, ship, truck, like that. Okay, so and another one, you just give the number. You just give the number as a 17. So you just find the image of 17. So 17 is the label 7. What is the image here? Horse image, right? So you just give us a text y is horse. So it means text y 17 is horse image. And what is the image here? So this is the title, right? So title is 7 and the image is what? Horse. Now normalized prediction, we just reshape. How many samples we have? We have one samples. So height and width is 32 and the color is 3. But just give the slash n. You can give the slash n here. It's enough. The y predict will be here. So the number starts with 0 to 9. So y predict here. I already told, right? So y predict. So see, this is the y predict. So this is the y predict. Which one is highest, guys? Which one is highest now? Highest number?
95.
9.5.
9.5.
9.5. So now see what's the index position. Zeroth index, first index, second index, third index. What is the index of 9.5?
3, 4, 5, 6, 7, 8.
No, it starts from 0. 0,
1, 2,
1, 2, 3, 4,
7.
5, 6, 7. What's the seventh position?
Yes.
So then only it predicts the horse image. Okay, these are the predicted values. So you want to see. So if you are using enumerate function, the first one is you people automatically takes as a index position, and the next key is y predicted. So you people are taking y predicted as a I, and I you already know I is a y predicted. So now you taken as a k. Okay, so y predicted and y max predicted should be in equal. The highest value should be equal to the k. Then only it predicts the label j. Have you got my point? So label j means what is the label? Now Gautam told, right? So label is 7, right? So what is the label 7? What is the label 7 is?
Yes.
Harsh. Then only depends. Do you have any doubts here, guys? That's all. Do you have any doubts?
So depending on the training data in the output of the softmax outputs, what is the highest matching number is getting the data from the database. Is
Yes,
it?
yes, yes.
So 95% is the highest matching value with the trained data.
Yeah.
That's why we got the 7 as horse.
Yes.
Okay.
Do you have any doubts? Guys, or else we can get the image from users, or else we can get the images from users. If you are uploading any images from the 10 classes, it automatically predict the images. It may be horse or bird or truck or anything. The 10 classes only, okay, not another, apart from others. Okay, if you have time you can try like that using ChatGPT. Do you have any doubts in this session, guys? Yes.
Nothing as of now, Vasan.